All right, let's get right into it. We're looking at a pretty groundbreaking new training recipe from NVIDIA, and it's seriously changing the game for how we cook up smarter, more capable AI.
Now, this whole new method comes straight from the researchers at NVIDIA, one of the biggest names out there, and it's already cranking out some absolutely stunning results.
And when I say stunning, I'm not kidding. An AI model that was trained using this new recipe just pulled off something that honestly felt like science fiction until now.
Get this, it snagged a silver medal at the International Olympiad in Informatics. We're talking about an elite competitive programming contest for humans. So having an AI place second against some of the best human minds on the planet, that brings up a massive question.
How in the world do you train a single AI to be a world-class coder, a creative writer, and a helpful assistant all at the same time without it just getting totally confused? Well, that is the exact challenge this new recipe was designed to solve.
And that brings us right to the core problem with the old way of doing things, what you could call the jack-of-all-trades dilemma. See, it turns out that just trying to teach an AI everything at once is a complete recipe for disaster.
Just think about it for a second. Complex coding. That requires slow, careful, step-by-step thinking, right? But a simple chat needs to be fast, it needs to be creative. These two skills have totally different demands, and trying to train an AI on both at the same time just creates this huge internal conflict.
The usual way to do this is to just mash all the training data together. The researchers had a great analogy for this. It's like trying to teach a student calculus and poetry in the exact same super chaotic lesson. And this messy approach leads to a very specific and very frustrating problem.
And that problem has a name: catastrophic forgetting. It's this tendency for an AI to just completely forget something it already learned the moment it starts learning something new. It's really the main villain of our story today, and it's been a massive roadblock for the entire industry, wasting tons of time and money.
So how did NVIDIA fix this? Well, they came up with this brilliantly simple idea, a much smarter way to teach, and they call it Cascade RL.
The core idea is actually pretty straightforward. Instead of that chaotic all-at-once approach, Cascade RL teaches the AI one subject at a time in a very specific order. It starts with a base of general knowledge, then it aligns with human feedback, and only then does it move on to the really specialized stuff. It's that organized sequential process that makes all the difference.
So let's take a closer look at how this cascade actually works, because each step is so carefully designed to build on the one that came before it. So here's the pipeline. It kicks off with what's called supervised fine-tuning, or SFT, which gives the AI its basic knowledge. Next up is RLHF, which is reinforcement learning from human feedback. That's where it learns to be helpful and safe. Then, with IFRL, it learns to follow complicated instructions. And only after all of that does it move on to the expert-level skills like advanced math and coding. You see, each step is a foundation for the next one.
And here's the absolute key, right from the researchers themselves. They found that training on the new skills, like coding, almost never hurt its performance on the earlier skills, like being helpful. In fact, sometimes it even improved them. They basically cracked the catastrophic forgetting problem.
And here's the visual proof. As the model goes through the different training stages, its abilities just keep going up. Nothing gets forgotten, skills just get added on top. This is a huge win against catastrophic forgetting.
Okay, so the theory is really elegant, but does this new method actually work in the real world? Let's take a look at the scorecard, because the results are, frankly, incredible.
And let's start with a really fascinating result that tells you pretty much everything you need to know, the moment the students surpass the teacher.
So check this out. The teacher model here, DeepSeek R1, is a monster, a 671 billion parameter model. It was used to generate the initial data. The student is NVIDIA's Nemotron-Cascade, a much smaller 14 billion parameter model. And on this really tough coding test, the little student model actually outperformed its gigantic teacher. I mean, that is just wildly efficient. And it wasn't a fluke either. If you look across the board at math, coding, and alignment tests, the Nemotron-Cascade models are consistently best in class. They're holding their own against, and a lot of times beating, much larger competitors.
So what you get at the end of this recipe is a smaller, way more efficient model that isn't just good, it's achieving state-of-the-art performance across a bunch of really difficult areas.
Okay, but this is about more than just setting new high scores. Let's talk about the bigger picture here and why this recipe really, truly matters for the future of AI.
One of the biggest breakthroughs here is the creation of a single, unified model. What that means is the very same AI can do both deep, methodical, chain-of-thought reasoning for complex problems, and it can give you instant, direct answers for simpler questions. You can just tell it which mode to use.
And why is that such a huge deal? Well, it just simplifies everything. Developers don't need to juggle separate models for different kinds of tasks anymore. They can use one super versatile AI, which makes building and deploying powerful AI way more efficient and accessible for everybody.
So let's just recap the big takeaways here. First, NVIDIA has a new sequential training method that finally beats catastrophic forgetting. Second, it lets us create smaller models that can actually outperform the giants. Third, it delivers a single, unified model that can handle all sorts of different needs. And maybe the most important part, NVIDIA is sharing this recipe openly with the entire AI community.
Which of course leaves us with one final and very exciting question. Now that there's an open recipe for building a smarter, more versatile AI, what are we, as a community, going to cook up next?